Okay, so we're going to resume from our last game, but in this one, we're going to show you how we're going to build the logic gates from the game. So we have 4 rows, and I could have done this as I moved along, but instead, what I'm going to do, yeah?
What are these for?
Oh, I'm not sure what that side is for. That's a good question. We'll figure that out. I'm going to fill these in, and then I'm going to show you how we could have done it as we went along. So in the very first row, I can represent that with binary, so we can get the students to do that. It's, we could say that is technically 1. And we had an OR gate, so I can represent it with the symbol, or I can write down the letter OR. And the purpose of this is what we're going to do is randomly generate our own circuit. In the next one, I had nothing, so you could just call that, that was the next, that's our second row, but there's no gates here, so we can kind of negate that if you like. Also remember that we have actually 4 inputs, so we could call them A, B, C, and D, and we're actually going to try to build a 4-input logic gate from this game. In row 3, so represented in binary here, I got 2 OR gates. So we're going to use these 2 OR gates. I can write it down like this, or we could use our symbols, our Boolean symbols for it. And in the 4th row, represented with binary, we got an AND gate. So this is great. I'm going to continue here. So I'm going to go with this. You know what? This guy's funny sometimes. Let's see. How did I do? None right? Oh man, okay. Well, at least I know it's not red, the color. So that would be the...
Daddy?
Yes, honey. The 5th one.
Can you give me a paper?
Okay, so there's our 5th one. We can negate that one, but you can see I'm starting to build a bunch of logic gates. Let's try this all the way across. How about now? Oh, here we go. 2? So 2 are correct. Okay, so this is great. I've built in 2 more AND gates. So this would be on my 6th one. On my 6th one, I got 2 more AND gates. So the point of that is we're going to continue up, and you're going to generate a bunch of more logic gates. Plus, you can use binary to figure out each row. From there, what the students can do is they now have their 4 inputs. So we can call them A, B, C, and D, if you remember. And I had 1 or 2, 3. Oh, I actually had 3 OR gates. So in round 1, we'll use binary to figure it out. Round 1, I had an OR gate, okay? So if they want, they can have multiple inputs into the OR gate. Maybe we do C and D, A and B, maybe there's 3 if we like. Really, we could just count our way through it. We could have just represented it with 1 if we want. In fact, that's the best way I think I'm going to do this, is we're actually going to just represent this as 1 OR gate. And we'll let C and D, they'll run into like the 2nd, 3rd round of the game. So we have an OR gate that's going to continue. In round 2, we had no gates, if you remember. Round 3, we had 2 more OR gates. So we have another OR gate and another OR gate. So maybe we represent that C and D go here to this OR gate in round 3. Round 4. Round 4, we got an AND gate. Okay, so we have an AND gate. So maybe we'll say the 2 OR gates build into that AND gate. Round 5 was nothing. Round 6 was 2 more AND gates. So what we can do here, and this is where you might have to get creative, because we've gone down to 1 input. We could also have from D, we could also say it branches maybe into here, and this one also branches here, and maybe A also branches into this AND gate, okay? So essentially that's how we're gonna build this circuit. And then after that, the students are gonna be in charge of building a truth table. So they'll have A, B, C, and D. They're going to run through all of their binary situations. So like if it's 0, 0, 0, if there's an input at just D, if there were no inputs, if there's an input at just C. So they're going to have a whole lot of options for that. And then they can write a Boolean expression with it. So in the end here, the idea is this game MasterMind is going to generate a randomly built up logic circuit, and then the students are going to be in charge of representing the rows in binary, building the representation of the logic gates, and building a truth table with it.